Hello everybody, welcome to Mathskpreet. Hope you're all doing good. So we were doing exercise 8.1 of grade 9. Let's proceed with the next questions of this exercise. So the question number 30 is saying that this is the given parallelogram and this diagonal AC is bisecting angle A. Bisecting means that it is dividing this complete angle A into two equal angles or equal measures. That means angle 1 is equals to angle 2 is given to us, and what else? ABCD is a parallelogram. And the first part is asking us to show that this same diagonal is bisecting this angle C as well. So I'm taking the names as angle 3 and angle 4. So here I have to show that angle 3 is equals to angle 4. So proof of first part, to show angle 3 is equals to angle 4. So what I have angle 1 is equals to angle 2, that is given to me. Fine. Now this is a parallelogram. AB is parallel to CD. Then by this, if AC is acting as a transversal, then this is a pair of angle 3 and angle 2 is making a pair of alternate interior angles. So we know that these angles will be equal. Why? Because AB is parallel to DC. So I'll write as AB is parallel to CD. Therefore, angle 3 will be equals to angle 2. Why? Alternate interior or alternate angles is enough to write. Alternate angles, a pair of alternate angles. Fine. Angle 3 is equals to angle 2. Similarly, as AD is parallel to BC, as AD is parallel to BC, therefore this is the pair now. Angle 1 is equals to angle 4. The pair in the form of Z is known as alternate pair. So angle 1 is equals to angle 4 with the same reason. Fine. Now I have angle 3 is equals to angle 2, angle 1 is equals to angle 4, and this is my number 1. I am writing this again. Angle 1 is equals to angle 4. But from number 1, angle 1 is equals to angle 2. So this 1 is equals to angle 2. This angle 2 is equals to angle 3. Like 2, mark it 3. Here we can write by using 1, 2 and 3. 1, 2 and 3. What I am getting? Angle 1 is equals to angle 4. Angle 4 is equals to angle 2. All the 4 angles are equal now. But I have to prove 3 is equals to 4. So I'll take 3 is equals to 4 from here. These two angles. So it's very simple. Now angle 3 is equals to angle 4, which means that this AC is bisecting angle C. Therefore, clearly AC is bisecting angle C. Proved. Market number 4. Okay. So according to my requirement, from number 4, what I can take from number 4, angle 2 is equals to angle 4. This angle is equals to this. These are basically, if ABC in triangle ABC, these two angles are equal. So the opposite sides to the equal angles will be equal. Why? Because this is acting as an isosceles triangle. So this result we have studied that sides opposite to the equal angles are equal. Therefore, what I am getting, this AB will be equals to BC. AB will be equals to BC or CB. Fine. So these two sides are equal. I have proved. As this is a parallelogram, therefore this will be equals to this. This side will be equals to this. Why? Because we have studied a theorem. We have studied a theorem that in a parallelogram, pair of opposite sides are equal. So we will again write as ABCD is a parallelogram. Therefore, pair of opposite sides will be equal. Then AB will be equals to DC and this CB will be equals to DE. So from these three equalities, I have proved that clearly, or therefore AB is equals to BC from here, or CB is equals to DC is equals to DE. From all these three equations, we are getting all the four sides of this parallelogram are equal. Therefore, it is forming a rhombus. This is for second part. Therefore, ABCD is a rhombus. Hence, both the parts have proved. Hope you understood. Let's see the next question. So the question number 4 is saying ABCD is a rectangle. Figure is not given to us. Let's draw it. So ABCD rectangle is given to us, in which diagonal AC bisects angle A as well as angle C. So here this diagonal is bisecting these angle A and C. Show that ABCD is a square. This is very similar to the last question. So it is given, we will write given angle 1 is equals to angle 2 as well as 3 is equals to angle 4. This is given to us. What else? ABCD is a rectangle is given to us. That means AB is equals to, what else? AB is equals to CD, opposite side, and AD is equals to BC or CB. Fine. Yes, show that ABCD is a square. To prove that this is a square, I have to show that all the four sides are equal. This is enough to prove, to show that ABCD is a square. So I have to show AB is equals to BC is equals to CD is equals to DA, or ABCD is a square. This I have to show. As we have proved in the last question, first I have to prove that these two angles are equal and these two angles are equal. After then, if these two angles we have proved equal, then by using that isosceles triangle property, we can show that these two sides are equal, these two sides are equal. So from here I can write all the four sides are equal. So I will write again, rectangle is a parallelogram, so angle 3 will be equals to angle 2, 1 will be equals to 4. As AB is parallel to CD, fine, therefore angle 3 will be equals to angle 2. Also AD is parallel to CB. Now these two are parallel, therefore 1 is equals to angle 4. Fine. Angle 3 is equals to angle 2. Angle 1 is equals to angle 4. Angle 3 is equals to angle 2, but this 2 is equals to 1. Mark it number 1 and 2. 3 and 4. From 1 and 3, what I am getting? 1 is equals to 2, 3 is equals to 2. Ultimately, I am getting 1 is equals to 3. From 1 and 2, 1 and 3 are equal, therefore 2 and 4 will be equal. If left is equal, then right hand side will be equal, so I am getting 2 is equals to angle 4. Fine. Now angle 1 is equals to angle 3 in this triangle ADC, here in ABC. In triangle ADC, here I will write in triangle ABC. In triangle ADC, these two angles are equal, then opposite sides will be equal. That means this side AD will be equals to DC. AD will be equals to DC or CD. And here in this triangle, these two angles are equal, I have proved, so opposite sides will be equal. You can write the property in the bracket that sides opposite to the equal angles of a triangle are equal. So therefore, AB will be equals to CB. Now by using number 5, number 6 and number 7, what I am getting from here, here and here, all the four sides are equal. AB is equals to CB is equals to CD is equals to DA. Therefore, ABCD is a square. To show that the adjacent sides are equal, just prove these angles equal by joining a diagonal that are making two triangles. You will ultimately get the adjacent sides are equal. When adjacent sides are equal, if the angle at the vertex is 90, it will form a square, and if not, then it is forming a rhombus. This is the procedure to show that this is forming a square. Next is diagonal BD bisects angle B as well as D. So here I have to show that. Let me draw one more figure, ABCD. Now I have to show that BD bisects this angle. I have to show these were 3, 4. 5 is equals to 6, 7 is equals to 8. Let me erase all this. What? Angle 7 is equals to angle 8 and 5 is equals to 6. As we know that AB is parallel to CD, here what? AD is parallel to CB. From AB is parallel to this, by alternate pair I am having angle 8 is equals to angle 5. Write the reason. Alternate pair of angles. Okay, we are doing same thing again and again. So 7 is equals to 6. 7 is equals to 6. I have to show 7 is equals to 8. This thing I have to show. If I show 7 is equals to 8, then ultimately 5 will be equals to angle 6. DC is equals to BC, so angle opposite to DC is 6 and CB is 8. Therefore, angle 8 or angle 6 is equals to angle 8. You can write here angles opposite to equal sides of a triangle are equal. Similarly, now these two sides I have written equal proved in number 1. So angle 5 will be equals to angle 7. Here you can write from part 1 I am writing. Okay. From part 1 we have proved that this is a square. Now 6 is equals to 8, 5 is equals to 7. Here I have proved I have written 8 is equals to 5, 8 is equals to 6. Then clearly by making use of market number 1, 2, 3 and 4. For this is the same reason here. Number 4. You can write from 1, 2, 3 and 4. But I can write 8 is equals to 5 and 5 is equals to 7. So I can write 7 is equals to 8. Fine. This was the thing that I have to prove, that BD is bisecting angle D. This is giving me BD, diagonal BD bisecting angle D. Also 5 is equals to 6 I have to show. 5 is equals to 8, 6 is equals to 7, but 8 is equals to 7. 8 is equals to 7, ultimately right side will be equal, therefore 5 is equals to angle 6. If 5 is equals to angle 6, this means BD is bisecting angle B. I hope you are able to see yes. So similarly I can write BD is bisecting angle C. So this was the proof for the second part as well. Very simple, very easy. Nothing we have to do. What was given, what we have proved in the last part, that this is a square, so these two sides will be equal. So this angle will be equals to this angle will be equals to this angle. What I have in my hands, that this angle is equals to this is equals to this by alternate pair of angles. Then comparing all these 4 equations, we can show that BD is bisecting both the angles, hence proved. Chalo, let's move to the next. So this is question number 5. Figure is given to us. ABCD is a parallelogram and P and Q are points on this diagonal BD. Find such that this side BQ is equals to DP. These two are equal. We can mark the sign. Fine. To show that triangle APD, which triangle APD? So I have not drawn the complete figure. I have just drawn the parts that I need in the part number 1. CQB. CQB means this. Let me draw these two triangles separately. APD. So AD is coming like this. This is P. Say. Fine. Here CBQ. So CB will be like this. This is Q. Fine. Okay, so I have to prove that these two triangles are congruent. This is first part. So here to show what I am having, AD, this side AD is equals to CB. AD is equals to CB. Why? Because this is a parallelogram, so opposite sides will be equal. So here AD will be equals to CB. Why? ABCD is a parallelogram. So this is a side. Next is what this is given to us. DP is equals to BQ. This is given in the question. This is again a side. DP is equals to BQ. Given to us. What else? In this parallelogram, these two are parallel side. This is a transversal. So angle D will be equals to this angle B. Why? Because alternate pair of angles. So this angle D will be equals to angle B. So I'll write this is an angle which is included. Okay, this side and the included angle. So angle ADB will be equals to CBQ. Why? Alternate pair of angles. Alternate angles. Therefore, by side angle side. Again I am telling side included angle and side we have proved equal to the second triangle. This rule of congruence, these two triangles we have proved congruent to each other. Please don't ever get panicked just by the statement or the figure. These two questions are very simple. Their figures are little complicated. We can see. So APD is congruent to first part we have proved. Second part that I have to show is AP is equals to CQ. This I have to show. AP is equals to CQ. This is coming from the first part by CPCT. AP is equals to CQ. I have to show equal. Therefore, from part 1 by CPCT. Okay. What I can write, the third side will also be equal of these two triangles. This is the reason and this is we have proved. But next, let me complete this figure as given in the book. What I have to show, AQB. AQB, this triangle. So this is the complete figure given in the question. Please don't mind my figures. So you can draw better in the notebook. So I have to show this triangle ABQ. Let me draw. AB is like this. This is CQ. To what? CPD. This is CPD. So if I have drawn AB, so I'll draw CD like this. So this is CD and with D we are attaching P. Fine. So these are the two triangles that I have to show congruent to each other. So clearly AB will be equals to CD. Let me write AB is equals to CD. ABCD. Yes. Why? ABCD is a parallelogram. So these opposite sides, pair of opposite sides will be equal. What else? BQ DP is given equals to us. Again, the same thing I am repeating. So BQ is equals to DP, that is given to us. Two sides we have proved DP. So this is the triangle and this is the triangle. So angle B will be equals to this angle D. Again by alternate pair of angles. You can write this is side, this is a side, this is an angle. I hope you are able to see. Yes. So angle ABQ. Okay, ABQ. ABQ will be equals to angle CDP by alternate pair of angles. By SAS criteria, we have proved that triangle ABQ is congruent to triangle CDP. ABQ congruent to CDP. CABQ. Okay. Therefore, by SAS criteria, we have proved that these two triangles, triangle AQB is congruent to triangle CPD. Okay. So number 1, number 2, number 3 and number 4 are almost similar. In the fourth part, we have to show that AQ is equals to CP. AQ is equals to CP I have to show. Therefore, by CPCT from part 3. From part 3 by CPCT, what I can write, the third side is equal. AQ is equals to CP. Proved. Okay, third side will also be equal. So these were the proofs for the first 4 parts. So in the 5th part, it is asking us to show that this inside figure APCQ, this is forming a parallelogram. So in the part number 2, I have proved that AP is equals to CQ. This side is equals to this side. And in the 4th part, I have just proved AQ is equals to CP. Fine. So from these 2 parts, collectively we can write it like from, for number 5 I am writing, from 2 and 4, we have, what we have, AP is equals to CQ, and what else, AQ is equals to CP. These are what, opposite sides of this quadrilateral, pairs of 2 pairs of opposite sides of this quadrilateral, which we have proved equal. So we have a result that when opposite sides or the pair, or both the pairs of opposite sides of a quadrilateral are equal, then it is a parallelogram. We have seen the proof as well of this theorem. So I can write now, therefore, APCQ is a parallelogram. The question was lengthy but not difficult at all. Not at all. So please don't skip such questions by just seeing the figure. These were the next 3 questions of this exercise. I hope you understood each and every step of the solutions and the questions. Till then, take care, study hard, hit like if you like, subscribe for more, and thank you for watching. Have a good day.